Welcome to my presentation. This is Lecture 005, continuation ng Lecture 004. So we have example number 1. Determine the tension in each segment of the cable shown and what is the value of H. So this is cable subjected to concentrated load. So solution. So we have free body diagram number 1. By inspection, ang una nating makukuha ay ang tension CD. So, kinat natin siya along segment CD. So, using summation of moment at point A, considering counterclockwise is positive, is equal to 0. Tension CD times the component along Y, so 4 over 5 times the moment arm is equal to 4 plus tension CD times the component along x-axis, so 3 over 5 times the component 4 meters. So minus 8 times 4 minus 3 times 2 is equal to 0. So tension CD is equal to 6.786 kilonewtons. Now for the AX, so summation of forces along X is equal to 0. So negative AX plus the value of tension CD times the component along X, so 3 over 5 is equal to 0. So AX is equal to 4.072 kilonewtons. Now for the AY, so summation of forces along Y is equal to 0. So AY plus the value of CD times the component along Y, so 4 over 5 minus 3 minus 8 is equal to 0. So ang AY is equal to 5.571 kilonewtons. Now for the magnitude of tension AB, so we have square root of AX squared plus AY squared. So tension AB is equal to the value of AX squared plus the value of AY squared, or is equal to 6.9 kilonewtons. Now for the tension BC, so free body diagram number 2 at joint C. So we have angle theta. So using summation of forces along Y is equal to 0. So tension BC times sine theta, so component along y-axis, plus the value of tension CD times the component along y-axis, so 4 over 5 minus 8 is equal to 0. So tension BC times theta is equal to 2.5712. This is equation number 1. Now, for the summation of forces along X is equal to 0. So, minus tension BC cosine theta. So, component along x-axis plus the value of CD times the component along X. So, 3 over 5 is equal to 0. So, tension BC cosine theta is equal to 4.0716. So, this is equation number 2. Divide equation 1 and equation 2. So we have so cancel out ang BC. So sin theta over cosine theta. So this is tangent theta is equal to 0.631496, or theta is equal to 32.272 degrees. So, using equation 1 or pwede rin gumamit ng equation 2. So, makukuha mo yung tension BC. So, tension BC is equal to 4.815 kilonewtons. Okay? Now, for the value of H, now, free body diagram number 3 tayo at joint B. So, we have tension AB, then tension BC, then the angle theta, then alpha. Now, using summation of forces along Y is equal to 0. So, we have 6.9 times the component along Y-axis, so sin theta, minus value ng BC times the component along Y, minus 3 is equal to 0. So, alpha is equal to 53.84 degrees. So, using the right triangle, so tangent 53.84 is equal to h over 2, or value ng h is equal to 2.74 meters. So, example number 2. The parabolic cable shown carries a uniform horizontal load of 20 kilonewtons per meter. So, compute the value of A, the tension of the cable at A, the tension of the cable at C. Then, yung point B, this is the point of tangency. So, solution. So, we have FBD1. So, we have H, TAY. Then, yung resultant ng 20 kilonewtons per meter. So, 20 times A at a distance A over 2 from point A. Then, we have FBD2. So, we have H, TCY. Then, the resultant, 20 times 30 minus A at a distance, so 30 minus A over 2 from point C. So, by inspection, yung H is constant at point A, point B, and then point C. Okay? So, using FBD1, summation of moment at point A, so considering counterclockwise is positive, is equal to 0. So, H times 12, yung moment arm. So, minus resultant times the moment arm. So, A over 2 is equal to 0. So, H in terms of A is equal to 5 over 6 times A squared. So, this is equation number 1. So, using FBD2, summation of moment at point C, considering counterclockwise is positive, is equal to 0. So, yung resultant times the moment arm, 30 minus A over 2, minus H times 6 is equal to 0. So, H in terms of A is equal to 5 over 3 times 30 minus A squared. So, equation 2. Equate equation 1 and 2. So, we have 5 over 6 A squared is equal to 5 over 3 times 30 minus A squared. So, using calculator, A is equal to 17.57 meters. Then yung H, using equation 1 or equation 2, so, value ng H, so we have 257.254 kilonewtons. So, since yung h is constant at point A, point B, and then point C, so yung h is equal to TAX and TCX. So, for tension at A, so using FBD1, so summation of forces along Y is equal to 0. So, TAY minus 20 times A is equal to 0. So, value ng A, 17.57. So, TEY is equal to 351.4 kilonewtons. So, yung magnitude ng tension at A is equal to square root of H squared plus TEY squared, or TA is equal to 435.5 kilonewtons. Okay? Now, for tension at C, using FBD number 2, so summation of forces along Y is equal to 0. So, TCY minus 20 times 30 minus A is equal to 0. So, yung value ng A, 17.57. So, TCY is equal to 248.6 kilonewtons. So, yung magnitude ng tension at C is equal to the square root of H squared plus TCY squared, or TC is equal to 357.745 kilonewtons. Example number 3. The suspension bridge in the figure shown is constructed using two stiffening trusses are pin connected at their ends C and supported by a pin at A and roller at B. Determine the maximum tension in the cable DE. The cable has a parabolic shape and the bridge is subjected to the single load of 50 kilonewtons. So, solution. So, we have FBD1. So, sa point A, so since naka-pin type, so we have AX and then AY. Sa point B, so naka-roller type, so we have vertical BY. Sa point A, we have horizontal H, then AY. And sa point D, ganun din, may horizontal H at by DY, no? So, yung horizontal H is constant all along the cable. Sa point D, sa point F, yung point F is the point of tangency. Then sa point E. Summation of moment at point A is equal to 0 considering counterclockwise positive. So, BY times 24 plus AY times 24 minus 50 times 15 minus H times 14 plus H times 14 is equal to 0. So, yung H times 14 cancelled out. So, BY times 24 plus AY times 24 minus 750 is equal to 0. So, common factor yung 24. So, BY plus AY is equal to 31.25. So, this is equation number 1. Now, for FBD2, so, in-isolate natin yung right side. So, since point C, naka-pin type, so we have CX, then CY. Then sa point of tangency or point F, so we have horizontal H. So summation of moment at point C is equal to 0 considering counterclockwise positive. So By times 12 plus Ey times 12 minus 50 times 3 plus H times 6 minus H times 14 is equal to 0. So common factor yung 12. So By plus Ey times 12 minus 8H minus 150 is equal to 0. So since By plus Ey, kung babalikan natin yung equation number 1, so ang By plus Ey is equal to 31.25. So times 12 minus 8H minus 150 is equal to 0. So ang H is equal to 28.125 kilonewtons. Now for the FBD3, solving for W or uniformly distributed load for the cable. So i-isolate natin yung cable. So every time na mag-isolate ka ng cable, so from any structures, so the cable is subjected to uniformly distributed load. So we have W. So the resultant, W times 12 at a distance 6 meters from point E. So summation of moment at point E is equal to 0 considering counterclockwise is positive. So W times 12 times the moment arm 6 meters minus H times 8 is equal to 0. So W times 12 times 72 minus 28.125 times 8 is equal to 0. So ang W is equal to 3.125 kilonewton per meter. Now for tension DE, so summation of forces along Y is equal to 0. So makukuha natin yung AY, no? So EY minus W times 12 is equal to 0. So EY is equal to 37.5 kilonewtons. So since may value na tayo ng H, may value na tayo ng EY, so makukuha natin yung magnitude ng tension EF. So tension EF is equal to square root of H squared plus EY squared, or is equal to the value of H squared plus the value of EY squared. So tension EF, so since naka-symmetrical ang cable, kahit na may load siya sa truss, so kapag in-isolate po yung cable, symmetrical pa rin siya, no? So yung tension EF is equal to tension DF is equal also to tension DE is equal to 46.875 kilonewtons. So this is the maximum tension, no? Okay?